Hi, my name is Vinh Nguyen and my student ID is 1014-88823 and this is my assignment 3 presentation for COM 3132. So let's just get started with overfitting. So this is the first accuracy plot that I got just right here. As you can see, the network does show the signs of overfitting starting around epoch number 10. At epoch 10, the training accuracy is about 71% and the validation accuracy is about 66%. After that, the training accuracy keeps climbing up all the way to 94% by epoch 45 for the validation. Accuracy actually drops down to 64%. This growing gap shows the model is memorizing the training data rather than learning the general patterns. So let's talk about the layers that we did before. The original model has 5 layers, a V2D with 32 layer filters, a max pooling 2D, a flatten, a dense with 128 neurons, and a dense with output 10. So what is the purpose of each layer? So Conv 2D scans the image with 32 small 3 times 3 filters to detect features like edges and textures. It uses ReLU activation for nonlinearity. And for max pooling 2D reduces the size by half by taking the max value in each 2x2 window. This reduces computation and makes the model robust to small shifts. And the next thing is flatten converts the 2D feature maps into a 1D vector for dense layers. Next we have dense 128 learns nonlinear combinations of features using ReLU activation, and dense 10 uses softmax to output a probability for each of the 10 classes like airplane, car, bird, cat, deer, dog, frog, etc. So next we have the extra conv layer and the comparison of them. Give me 1 second. Okay, so for question 6, I added a second conv 2D layer with 64 filters and another max pooling 2D layer. This model now has 7 layers instead of 5. Comparing the second accuracy plot to the first one, the deeper model achieves higher overall accuracy because the extra convolutional layer lets it learn more complex features. However, it also shows more overfitting. The gap between training and validation accuracy is larger because of the increased number of parameters. So the third model, for question 8, I added a dropout layer with a rate of 0.5. Just give me a second. Yep. Just there you go. So after the dense 128 layer, the model now has 8 layers. Dropout works by randomly turning off 50% of the neurons during each training step. This forces the network to spread its learning across many neurons instead of relying too heavily on a few. So it acts as a regularization to reduce overfitting. So looking at the third accuracy plot, the gap between training and validation accuracy is now smaller compared to the previous models. The training accuracy is a bit lower, but the validation accuracy is better, which means the model generalizes better to new unseen data. So that concludes my presentation for assignment 3, and thank you so much for watching.